Welcome. Today I'm going to try to guess the answers to some questions in Explain Like I'm Five on Reddit. So let's start with the first one. Why smaller piece of ceramic is tougher than larger piece of ceramic? Yesterday I accidentally dropped a ceramic plate and it broke in two pieces. I picked up one of the pieces and dropped it. It didn't break when dropped once, and I have to drop it harder a few times to break it into smaller pieces. Then I picked up one of the smaller pieces and repeated the same process. No matter how hard I dropped it and how many times I dropped it, the smaller piece simply will not break. It's as if the smaller piece became indestructible. Why is smaller piece of ceramic significantly harder to break than larger piece of ceramic? So I think this might be an obvious one, but I'm going to guess this is because the larger piece of ceramic is, well, larger. So it has a lot more space to break, right? Whenever it crashes against the floor, it just has more pieces to break off. But when it's a smaller piece, it doesn't have that much space, that much mass to break. So I think it's probably that. It doesn't have that much space. So let's check the top comment. It says at the point its total mass is less, so there's not as much energy or force behind it when it falls and hits the ground. It's basically the same reason an ant or fly can fall off a desk and be perfectly fine. But if we took a comparable fall from even half the height, we'd be dead. So I think I was going in the right direction, right? So there's not much energy or force behind it when it falls and hits the ground. So I think I'm going to say I was correct in that one. Let's check the second one just in case. It's not just ceramic. You can drop a mouse down a 1,000-yard mineshaft, and on arriving at the bottom, it gets a slight shock and walks away. A rat is killed, a man is broken, a horse splashes. So yeah, basically the bigger the item, the harder the fall, right? Okay, let's go to the next one. Why don't we put solar panels in our parking lots? Parking lots are big flat areas that get a lot of sun and are already cleared and paved. Putting solar panels over them would not only make electricity but also provide shade for cars at the same time. Is cost the only reason why this isn't done more often, or are there other bigger obstacles? This is actually a really good question. Why exactly don't we do that? It seems like a very logical explanation. I mean, I'm guessing it's going to be like a combination of, because we're not able to put them on the ground, right? So they're going to have to invest more money into making like a roof for the cars that they can put the panels on, because I don't think they can simply put them on the ground. So I'm going to say it's going to be like cost related, because it's going to be more expensive to add the roof and then add the solar panels. And also the solar panels are expensive themselves, right? Okay, let's take a look at the first answer. It says, it is done in some places, but the main issue is cost. See? In general, landlords typically own the shopping complex and tenants lease it and pay their own utilities. The tenants have no incentive to add solar panels, and neither do the landlords. Only in places where the company owns and uses the complex would it make sense. But again, it costs a lot and typically takes 10 to 15 years to break even. So yeah, basically what I was thinking, it's mostly a cost issue. It doesn't make any financial sense to add those solar panels as a roof. So the second one says mostly a cost issue. I see it in places that are sunny much of the year, so they pay for themselves more quickly. The cost benefit math makes a lot more sense in Phoenix than it does in Chicago. That's another good point that I wasn't considering. It doesn't really apply to all locations. There are a lot of locations that are sunnier and a lot of locations that are not. So you also have to consider the climate of where the parking lot is located, right? So it's not always a viable option. Okay, let me take a look at the next one. How is electricity stored, and how can it be imported or exported to other countries? I think I'm kind of familiar with this one. I think electricity is stored like in some kind of cells, if I'm not mistaken. Like there's like tiny little containers for electricity, and that's what I've always thought of how they store it, right? I'm not sure. Let's take a look. So the top comment says, So you're confusing two things. Batteries store electricity by converting the electrical energy to chemical energy in a way that allows a chemical reaction to take place later that produces electricity again. I'm sure other posts will explain this more. But when electricity is exported or imported, it isn't in a stored form. We're not shipping huge batteries around on boats across the ocean. We simply connect big power lines across international borders. The electricity in power lines doesn't come from storage. It gets generated in real time. The electricity running the lights in the room you're in was generated from a turbine at a power plant a few milliseconds ago. The power plants are constantly adjusting how much output they produce to match what people are currently using. Okay, so I was definitely wrong on this one. So it's not any battery cells that I was thinking of. It's mostly transfer directly and immediately, right? And let's do one last one. It says, how do crops grown repeatedly on the same soil over many years continue to obtain nutrients after previous crops have already used them? Crops are continuously grown on the same farmland every year. How do plants receive nutrients when earlier crops have already depleted the soil? For this one, I'm guessing it's more of a combination of farmers and owners of the land filling the soil with the vitamins they require. So basically, just like fumigation or any other kind of delivery of vitamins they can do. And yeah, that's what I would guess is the reason they're able to constantly receive nutrients even after the previous crops have already used them. So let's see the first answer. Not all plants use the same nutrients. Farmers use crop rotations to regenerate nutrients. For example, crop A loves to take in nitrogen and produces phosphorus waste. If you only grew crop A, eventually the field would be devoid of nitrogen and saturated with phosphorus, making it impossible to grow more crop A. But if you periodically plant crop B instead of A, which takes in phosphorus and excretes nitrogen as waste, then you can maintain a nutrient balance in the field. Several microorganisms can also replace nutrients in the soil. Also, farmers use lots of fertilizer to replace lost nutrients when they can rely on natural methods like crop rotation. Okay, so I don't think I was that off. I mean, besides from the crop rotation thing, it does mention like the farmers using like fertilizer. So that's basically the point I was trying to make, right? Let's go ahead and take a look at the second comment. It says two ways. Old school, often you let soil sit fallow for a year by planting legumes on it. New school, fertilizer. So yeah, I'm thinking I had like half correct answer there. But yeah, pretty happy with my results. I'll give it a 2 out of 4 for my score. Let me know what you guys thought of those questions and if you got them all correct. Bye.